Okay, so welcome to day 4. This is geometry. This is Mr. K speaking. Hopefully you guys have been keeping up with your studies here. All right. Hope everybody's staying safe. And it's important you guys stay on top of your studies here, okay? Because we don't want to lose all that progress we made in preparing for this region. So hopefully you guys are keeping up with these. Anyway, so this is day 4, okay? And so what are we looking at here? So it says a walking path at a local park is modeled on the grid below. Where the length of each grid square is 10 feet, the town needs to submit paperwork to pave the walking path, determine and state to the nearest square foot the area of the walking path. Ooh, excuse me. Okay? So we are trying to find this area right in here. Okay? That's what we're trying to find. All right? And so let me draw a couple squares on here. So the first thing we're going to have to do is we're going to have to find... Now I'm going to get a brighter color here so it stands out. We're going to have to find this square here. Let me zoom in here. Or not square, I'm sorry, this rectangle. We have to find the area of that rectangle there. Then we're going to also have to find the area of this rectangle. And then to get that space in the middle, we're just going to subtract the area of the larger one by the area of the smaller one. And what remains will be this spot, or this space right in here. Okay? So, let's take a look. So, this length is 1, 2, 3, 4, 5, 6, 7, 80 feet. Okay, because don't forget that there are 10 feet. Each length is 10 feet. All right? And so then this length, 1, 2, 3, 4, 5, 60 feet. Okay? So in order to find the area of that first rectangle, don't forget the area of a rectangle is just length times width. So in this case, it's just 80 times 60. Which is 4,800. Okay, so that is, 4,800 feet squared. Okay, so that is the area of the outside rectangle. Now, we want to subtract, let me get a different color here. We want to find out what this area is in here and subtract it from the larger one, from the larger area, and we'll be left with the stuff in the middle. Okay, so this smaller rectangle, right, still has a length of 80 feet. Oops. Okay, but the difference is it has a width of only 1, 2, 3, 4. Or not, sorry, 40, sorry. Okay, so it's 8 times 40, which is 3,200. And so the grand total, this spot in the middle here, this pink stuff, all right, so let me erase all this other extra. Okay, this little pink section right here, it's the only area we're finding, or the only area we're finding this far, is going to be represented by 4,800 minus 3,200, which is 1,600, or 16,000 feet squared. Okay? So this section right here, this right here, and that piece right there is 1,600 feet squared. All right. Okay. Moving on here. Looks like I felt like I made a mistake, but I guess not. So let's move on. So the next piece is we need to find, put in a different color here, this area right here. All right. So if you look, let me get different colors here. Okay. This outside part here. Okay. And this outside part here, if we put it together, we would get a whole circle. Okay. And now let's just measure what the radius would be. The radius would be this part to this part right there. So our radius for that outside circle would be 3. And if you look, it's 3 all the way around, right? So we know that when I put these two sections together, okay, since our radius is, or since if you look on all these sides here, okay, look at that red spot, this is 3, this is 3, this is 3, so it lets us know our radius is 3, right? So in order to find the area of that outside circle, right, because we got one section over here, we got one section over here. So all we got to do is find the area of that one circle, and then subtract it by the area of that inner circle here. Okay, same process we did with the rectangles, except we're dealing with a circle. Okay, so to find the area of that circle, it's pi times 3 squared, pi r squared, which is just 9 pi. Right? The area of that inner circle, okay, so let's take a look at what that one looks like. Whoops. Okay, so here's that inner circle. As you can see, this has a radius of 2. This is 2, that length is 2, that length is 2. So when we put these two things together, we got a circle with a radius of 2. Okay? So to find the area of that circle, it's pi r squared, which is 9, or I'm sorry, not 9 pi, 4 pi. And then to find the area that's left, okay, find that space in between, we take the larger one, which is 9 pi, minus the smaller one, which is 4 pi, and we should be left with that space in between, which is 5 pi feet squared. Notice I'm leaving it as 5 pi because it's just a much cleaner number. All right, we all know what pi looks like. It's 3.14159.265. All right, just a big, long, ugly number. I think 5 pi makes it look a little nicer. All right, ooh, I'm sorry. I messed up one thing, didn't I? That's supposed to be 20. So actually, this is supposed to be 30. All right, would be the radius, and that 20 would be the radius there. So this is actually going to be 30 squared is 900 pi. And this one is 400 pi. My bad. Ooh, okay, good catch. Felt like that would be really small. All right, that was what this is feet squared. This is feet squared. That's what we have left. It's 500 pi feet squared. All right? So we add those two things together. All right, so it's going to be 500 pi plus 1600 You end up with 3170.796. And so determine and state to the nearest foot, nearest square foot. So our nearest square foot is 3171 feet squared. And so that is the area of our shaded region. All right, let's take a look at number 2. Hopefully you guys got that okay. Sorry about that mistake there, but hopefully that's what you guys got for your answer. Okay. Next one. The greenhouse pictured below can be modeled as a rectangular prism with a half cylinder on top. The rectangular prism is 20 feet wide, 12 feet high, and 45 feet long. The half cylinder has a diameter of 20 feet. Okay. All right. So in order to find what this volume is going to be, so to the nearest cubic feet, what is the volume of the greenhouse? What we're going to have to do is we're going to have to find, well, let me make a better one. Hold on a second. I can do better than that. Okay. Zoom in here. All right. Okay. So there is our rectangular prism. All right. And then what we're also going to have to find is we're going to have to find the volume of the cylinder on the top. And then we're just going to have to cut that volume in half. Okay, so you'll add this volume with half of the volume of the cylinder. So that is our plan here. Okay, ladies and gentlemen. So, that being said, let's get started. So in this one, this is 12, this is 20, and this is 45. And remember to find the volume of a rectangular prism. It's just length times width times height, which in this case is 12 times 20 times 45. And then you multiply that all out. You should get 10,800 feet squared. Okay? 10,800 feet squared. Okay, so that is the volume of the rectangular prism. Now we need to find the volume of the cylinder and then divide it by 2. Okay, so they give us the diameter of 20. And don't forget our radius, well, so that's what we're going to need, pi r squared times our height. Okay, we need to find out what this radius is. Now they give us our height. Okay, our height is just the length of this rectangular prism. Okay, so our height is 45. So we just need the radius. So in order to find the radius, we're going to take our diameter and divide it by 2, which is just 10. And when you hash all that out, you should get this number right here. Okay? 14,137.16694 feet squared. And then we're going to take that number, we're going to divide it by 2, And so our volume is now 7,068 point, I'm going to round it, I'm going to say 5.8. Okay? And this is feet squared. Now I'm going to take this number, I'm going to add it with this one up here. So plus 10800. And you should get a volume of 17,868.58. And what's it say? It says to the nearest cubic foot. So we're going to have to round that up. So our answer is that one right there. Okay, so not too crazy of a problem, where we just had to find the volume of the cylinder and the rectangular prism, right? But we just had to remember, once we find the volume of the cylinder, we had to divide it by 2, because we only needed the volume of half of that. Okay. Anyway, so that's number 16. Let's go down to number 17. Okay, so number 17 says the base of a pyramid is a rectangle with a width of 4.6 centimeters and a length of 9 centimeters. What is the height in centimeters of the pyramid if the volume is 82.8 centimeters cubed? Okay, so in this one they've already given us what the volume is. So it's our job to determine the height. So we got to remember, all right, it's a pyramid with a rectangular, the base of a pyramid is a rectangle. Okay, that means, oops, that's not good. Okay, that means, sorry, the base of our pyramid is a rectangle with a width 4.6 and a length of 9. This is in centimeters. So it says, what is the height in centimeters of the pyramid if the volume is 82.8? So let's remember, let's write down how to find the volume of a pyramid. Okay, and it is 1/3 times the big B times our height. Okay, and this is for pyramids. All right, so let's think about what the big B stands for. The big B stands for the area of the base. And therefore, in order to find the area of the base, we're going to multiply 4.6 times 9. You should get 41.4 centimeters squared. And that is the area of our base. All right, and then I think we can fill in the rest of this. All right, the only thing we can't fill in is our height, right? So they give us the volume, which is 82.8. Here's the rest of our formula: 1/3 times the base, which is 41.4, times our height, which we don't know. All right? So when you simplify on the left, you get 41.4 times 1/3. So you get 82.8 is equal to 13.8 times h. Divide both sides by 13.8, and you get h is equal to a nice even number, or a nice even and whole number, 6. All right, so the height of this pyramid is 6, which, do we see that? We sure do. Okay, it's cool. Always makes you feel good when you see the answer there. All right, 2 more problems, guys. So this one, there's a couple ways you could have gone about this. So when I first solved it, I actually did the long way, and then I went and looked up the answers and saw a much easier way of solving this thing. Okay, so let's start. So I'm going to create a square. Okay, so I'm going to first draw in these 3 triangles, and you'll see why I'm drawing these in here. Once I get there. Okay, so let me scroll in here. Well, you really can't see that. Get a thicker pen here. How's this? Whoa. Heyo. Well, that's no good. How about this one? Perfect. Okay, so here's our 1 triangle. Here's our other triangle. And here's our last triangle. Okay, why did I just draw those in there? Well, if you look, it appears that we have, is this a square or rectangle? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is 11, and this is 12. So what we just did was we created ourselves a nice rectangle. Okay? So, let me just draw this in a little nicer for you guys. I don't want such a big pen this time. So, there's that one. There's that one. That one. And that one. So what I did was I just created, pretty much I inscribed the triangle inside of this rectangle. All right, and you're probably wondering, why the heck would you do that? Well, because it's asking, all right, wants us to find the area of this triangle. Now, unfortunately, right, in order to find the area of a triangle, you need the base and the height. And because this isn't a right triangle, our height would actually be somewhere about there. Okay, it must go from the one vertice to the opposite end and create a perpendicular line. All right. So it would be located somewhere about there. Now, I know this because that is how I solved the last problem. Was I found the height of this triangle. And then I saw how they solve it, and this is so much easier. Okay, so what I did was I enclosed this triangle. Now, as you can see, all 3 of our vertices fall on the end of this rectangle. Okay, so this is as tight to this triangle as I can get without going over the vertices. All right, so our vertices are all touching this rectangle at some point. Okay. Now, the reason why I enclose this triangle, because if you look, okay, I've created 3 new triangles, which now they're all right, okay, which means we can find their base and their height. The base and the height. The base and the height. All right? We can only do this, or we can do this with these 3 particular triangles because they are right triangles, right? They give us the height right there. Right? The height is represented by those 3 lengths, and the base is represented by those 3 lengths. Okay? So, anyway, so our goal here, if you haven't thought of it already, is I'm going to find the area of this entire rectangle, and I'm going to subtract the area of those 3 triangles, and the area I should have left should be this shaded region. Okay? So that is our plan. If you came up with another idea of maybe finding the lengths of these sides and then finding what the altitude is, there is another method, but this is the quickest. Okay? So by creating these 3 triangles, what I've did is I've inscribed this triangle, and now I can find these 3 areas. Okay? So let's find the area of this triangle here first. Okay? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, so this length is 12. This length is 1, 2, 3, 4. All right, so to find the area of this one here, it's going to be 1/2 4 times 12, which is equal to 0.5 times 4 times 12 is equal to 24. We'll just say units squared. All right. To find this one here, I'm going to count up the side here. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So this length is 9. This length is 1, 2, 3, 4, 5, 6, 7. So to find this area, it's going to be 1/2 7 times 9. So 7 times 9 is 63. Divided by 2, 31.5. And to find this area here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And this one length is 3. So the area is 1/2 3 times 11. Which is just 11 units squared. All right, so, and then our main squeeze here is we want to find the area of this whole rectangle. So let's count it up. So I know this is 12, this is 11, so the area of that rectangle is 11 times 12 is equal to 132. So you're going to go 132 minus 11 minus 31.5 minus 24, and we should get 60. Uh-oh. Well, that's not good. What happened? Did I type in something wrong here? I'm getting 65.5. That is not the answer. The answer is 60. How is it that I got that right there? I screwed up here somewhere. Where did that go wrong? 1, 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7, 8, 9. Yep. I see what I did. Oh my gosh. Don't you love when that happens? All right, so here we go. So 1/2 times 3 times 11. You should get 16.5. Yes. All right. So it's not 11. I screwed up somewhere. Come on, Eric. So minus 16.5. So when you minus all that out, there it is. Minus 16.5, minus 31.5, minus 24. And you get 60 units squared, which we see right there. Should make you feel pretty good. All right, so anytime you see a problem like this, all right, in order to find the area of a triangle, okay, you got to have its height. And unfortunately, in this triangle, because it's not a right triangle, all right, we had to kind of think outside the box. In this case, we enclosed it in a box, okay, and by doing so, all right, it allowed us to find these three heights, or these three areas. You know, we could find their base and their height, all right, and then once we find those three areas, we subtracted it from the big rectangle. And then that's how you should come up with 60 units squared. Okay? So hopefully that helps you guys out in that sense. All right. Let's look at Randy's basketball here. All right, this one shouldn't take too long. So Randy's basketball is in the shape of a sphere with a maximum circumference of 29.5 inches. Determine and state the volume of the basketball to the nearest cubic inch. Okay? So the volume of a sphere is 4/3 pi r cubed. Okay, so we don't know what the radius is. They give us the circumference, and so we can find our radius just by kind of backtracking. So the circumference of a circle is c is equal to pi times r times 2. All right, and so in this case, our circumference is 29.5 times pi times r times 2. Okay, so we don't know what r is, but when we divide both sides by 2 pi, that is r is equal to 4.69, we'll go 5.1, okay, inches. All right, so now we have our radius. We can just plug it right in here. So 4/3 times pi, radius is 4.6951 cubed. So 4/3 times pi. Whoops, times second answer cubed. I'm getting an answer of 433.526. It says round to the nearest cubic inch. So we go 434 inches cubed. Okay, so that is the answer to number 19. All right. So the rest of these will be posted here. Just stay tuned for more answer keys and more work coming. All right, be in touch. Keep emailing. All right, email me your work. Email me when you don't understand something. Email me when you got questions. Just make sure you guys are consistently staying in contact if you have any issues with what we're doing and what it is I want you guys to accomplish for me. Okay? So anyway, hopefully you guys are having a good little time away from school. But let's just make sure we're still staying on top of our studies, guys. All right?